The Sun is a thief. For over 4.5 billion years, it has worn the disguise of a quiet, stable, well-behaved star. The anchor of our solar system. The reliable furnace at the center of everything we know. Predictable, steady, ours. But buried in its history is a crime, and the evidence has been hiding in plain sight for a very long time, drifting in the cold dark beyond Neptune, where almost nothing should exist at all. Astronomers now believe at least one object orbiting our Sun did not begin here. It was not born from the same disk of gas and dust that built Earth and Jupiter and Mars. It came from somewhere else. Another star, another system. And our Sun, in its violent youth, reached out and took it. This is the story of how that theory was assembled, what it might mean for our place in the galaxy, and why the more we look at the edges of our solar system, the harder it becomes to see this place as a closed neighborhood. We are not alone in the universe in the way you've been told, and not because of life, because the very ground we orbit on may have been stolen from another sun. To understand the crime, you have to understand the scene, and the scene is older than Earth itself. Our Sun did not form alone. Stars almost never do. Roughly 4.5 billion years ago, the Sun was one of thousands of stars condensing inside a vast stellar nursery. A collapsing cloud of gas and dust that astronomers call a birth cluster. Imagine a city of newborn suns, packed close enough that their gravity tugged at each other. Close enough that the night sky on any infant planet would have been blinding. Multiple suns visible at once. No darkness anywhere. Just a glowing crowd of young stars elbowing each other in a tight crib. In that environment, things didn't stay where they belonged. Stars passed each other at distances that, by today's standards, are unthinkable. Within a fraction of a light year, sometimes closer. When two stars came that close, their planetary systems brushed against each other. Loosely held objects on the outer edges, comets, dwarf planets, even full-sized worlds, could be tugged from their original orbits and dragged into the gravitational well of a passing neighbor. That neighbor, in some cases, was our Sun. The cluster lasted maybe 100 million years before it dispersed. The siblings drifted apart, scattering into the galaxy, leaving the Sun and its captured family behind. Some of those siblings have actually been identified. HD 162,826, about 110 light-years away from us, is a confirmed solar sibling, born in the same cradle. There are likely thousands more of them spread across the Milky Way, each carrying their own stolen and gifted objects. The result of 100 million years of cosmic shoplifting. That is the setting. A crowded nursery full of stars too close to each other for too long. The question is whether our Sun came away with anything. The answer is in the orbits. In November of 2003, 3 astronomers, Mike Brown of Caltech, Chad Trujillo, and David Rabinowitz, found something strange. A reddish object, about 1,000 kilometers across, drifting through the dark beyond Neptune. They named it Sedna, after the Inuit goddess of the sea who was banished to the bottom of the ocean by her father. The name fit, because Sedna was banished too. Its orbit didn't make sense. Most objects in the outer solar system follow paths that can be traced back to gravitational interactions with the giant planets. Neptune, in particular, is a kind of orbital cop. Things that wander too close get redirected, scattered into looping orbits that eventually pass back near Neptune again. That's how the Kuiper belt works. That's how comets behave. Touch Neptune's gravitational influence, and your orbit carries the fingerprint forever. Sedna doesn't have that fingerprint. Its closest approach to the Sun is about 76 times the Earth-Sun distance. Far beyond Neptune, far beyond anywhere Neptune's gravity could have reached, even at its most extreme. At its farthest point, Sedna swings out almost 1,000 times the Earth-Sun distance, then begins the long, slow fall back inward. A single orbit takes about 11,000 years. The pyramids were being built the last time Sedna was where it is today. And Sedna is not alone. Since its discovery, astronomers have found a small handful of similar objects. 2012 VP-113, nicknamed Biden. Lele-Akuhonua, sometimes called the Goblin. Other detached objects out in the dark, all sharing one suspicious feature. Their orbits are too far to have been shaped by any planet we currently know about. Their existence is, on the face of it, impossible. So how did they get there? This is the central question, and it has a few possible answers. The first answer is that Sedna and its companions were placed in their strange orbits by a large, unknown planet hiding even further out. This is the famous Planet 9 hypothesis, proposed by Mike Brown himself along with his Caltech colleague Konstantin Batygin in 2016. They noticed that the most extreme detached objects share a curious bias. Their orbital paths point in roughly the same direction. The probability of that being random alignment is less than 1 in 10,000. A massive, undiscovered planet, somewhere between 5 and 10 times the mass of Earth, orbiting hundreds of times farther than Neptune, would explain the pattern. Its gravity would shepherd these tiny worlds into the strange alignment we observe. As of now, Planet 9 has not been directly detected. Searches are ongoing. The Vera C. Rubin Observatory, which began full sky operations recently, has the best chance of finally catching it, if it really is out there. But Planet 9 itself raises a much bigger question. If a planet that big really is out there, where did it come from? It is too far from the Sun to have formed in place. The disk of gas that built our solar system thinned out long before reaching those distances. So either Planet 9 formed closer to the Sun and was kicked outward by a violent gravitational encounter early in solar system history, or it didn't form here at all. In a 2018 study, astrophysicists Amir Siraj and Avi Loeb at Harvard ran the numbers. They found that the probability of our Sun capturing a free-floating planet during its time in the birth cluster is non-trivial. Not high, but not negligible. If Planet 9 exists, there is a real, calculable chance that it was not born in our solar system. It was caught. That changes the entire picture. Our Sun didn't just steal a few small icy bodies on the outskirts. It may have stolen an entire world. A planet larger than Earth, ripped from the gravitational grip of another star and dragged across the cold dark into ours. Slow down for a moment and think about what that actually means. If you were to fly to Planet 9, assuming we one day find it, you would not be visiting a sibling of Earth. You would be visiting a refugee. A planet ripped from its original sun, dragged across the gulf between stars, and absorbed into a system that was never its home. Its rocks, its core, its chemical signatures would all be foreign. They would carry the memory of a different birthplace, a different sun, a different family of worlds it once orbited alongside. Imagine standing on its surface, if it has one. The night sky above you would not look quite right to anyone trying to navigate by the stars. The sun in this sky would be a faint pinprick, no warmer than the brightest star you can see from your backyard tonight. From Planet 9's distance, our sun would not be a giver of life. It would be a gravitational warden, a jailer, the thing that captured this world long ago and never let it go. And it would have done it silently. There was no impact, no dramatic moment, just gravity, doing what gravity does over millions of years, slowly bending the trajectory of an object passing too close until it was no longer passing at all. The mechanics of capture are surprisingly elegant. When a star with its own loosely bound planets drifts past another star, the gravitational pull of the second star can disrupt the first one's outer system. A planet that was in a wide, fragile orbit around its parent star suddenly finds itself caught between two competing gravitational fields. If the geometry is right, if the speeds line up, if the angle is favorable, that planet can be transferred. It loses its old sun and gains a new one. Often it ends up in a wildly stretched, eccentric orbit, much like Sedna's, or much like the orbit Planet 9 is theorized to have. Computer simulations, run by teams including Susanna Faltzner at the Max Planck Institute, have shown that this kind of stellar theft is not just possible, it's expected. In a typical birth cluster like the one our Sun came from, anywhere from 1 to a few % of all small icy bodies in a star's outer system might be captured rather than native. That's a small percentage, but in a region like the inner Oort cloud, which contains potentially trillions of objects, a small percentage adds up to an enormous number of stolen worlds. There may be billions of objects in our solar system that did not originate here. That is not metaphor. That is the math. Now, the search for proof is harder than the math. Capture leaves clues, but they are subtle. The strongest signal is orbital. An object that was born in the disk around the young sun should have an orbit roughly aligned with the plane of the planets, because that disk was flat. An object captured from another star should have an orbit that is tilted, sometimes wildly, because it came in at a random angle. When you look at the detached population, the objects orbiting beyond Neptune in those weird stretched paths, you find tilts. Sedna's orbit is tilted by about 12 degrees from the plane of the planets. Some of its companions are tilted further. The Goblin sits at 24 degrees. Other extreme trans-Neptunian objects are at 30, 40, 50 degrees. A few are nearly perpendicular to the rest of the solar system. Those tilts are not what you'd expect from objects born here. They are what you'd expect from objects that arrived here. The second clue is chemical. The gas and dust cloud that formed our sun had a specific recipe of elements and isotopes. Different stars born in different parts of the galaxy at different times had slightly different recipes. If we could analyze the surface composition of one of these suspect objects, we might find chemical signatures that simply don't fit our solar system's bookkeeping. They would point to a different star with a different birth chemistry, light years away in space and millions or billions of years away in time. So far, we don't have detailed surface composition data for most of the candidates. They are too small, too far, too dim. Sedna is bright enough to study a little. Planet 9, if it exists, would give us much more to work with. The James Webb Space Telescope and the new generation of ground-based giants will, over the next decade, push our ability to characterize these objects far beyond anything we've ever had. If even one of them turns out to have a chemical signature that doesn't match our sun's, the case is closed. The sun is, beyond reasonable doubt, a thief. There is another piece of evidence, and it is a strange one. We have already seen interstellar objects pass through our solar system in real time. In October of 2017, a small reddish elongated object, now called Oumuamua, came barreling through the inner solar system at a speed and angle that proved beyond doubt it was not from here. It came in fast, looped around the sun, and left, never to return. 2 years later, in 2019, an amateur astronomer named Gennady Borisov spotted a comet, now called Borisov, on a hyperbolic trajectory. Same story. Came in from interstellar space, made one pass, and is leaving forever. 2 confirmed visitors in 2 years. After centuries of looking, suddenly 2 of them, almost back to back. Astronomers now estimate that at any given moment, there are several thousand interstellar objects of significant size somewhere inside our solar system. Most are too small or too dim to detect. They are moving too fast for our sun's gravity to capture them. They will leave, just as Oumuamua and Borisov did. But not all of them. A small fraction will arrive at exactly the right angle, at exactly the right speed, with exactly the right gravitational interaction with one of the giant planets to be captured. They will become permanent residents. Astronomers have already identified a few suspected captured asteroids, including a small object called 2015b Z509, which orbits in the opposite direction of every planet in the solar system. That kind of retrograde orbit is essentially impossible to produce naturally from our sun's spinning birth disk. Its discoverers concluded that it was almost certainly captured from another star. It has been hiding in Jupiter's gravitational shadow for billions of years, going the wrong way around the sun, and almost no one noticed. Each of these objects is a fingerprint, a small, quiet piece of evidence that the sun has been stealing for a very, very long time. What does it mean, then, to live in a stolen solar system? It means that the boundary between us and them is much fuzzier than we used to think. We have always told ourselves a clean story. The sun formed, the disk formed, the planets formed, Earth was assembled from local materials, life on Earth came from local chemistry. We are a closed system, separated from the rest of the galaxy except by the long arm of starlight. That story is, if not wrong, then at least incomplete. If even a small fraction of our outer solar system was captured, then those objects carry information from elsewhere. They carry chemicals from other stellar disks. They may carry ice from the cold edges of other systems. In the most extreme version of this idea, some of the comets that struck Earth, delivering water and organic molecules, may not have originated in our sun's family at all. Some of the ingredients that built the oceans, that seeded the prebiotic chemistry of early life, may have come from the disrupted outer reaches of other suns, captured into ours during a chaotic infancy 4.5 billion years ago. That's not poetry, that's chemistry. The water in your body may not have all started here. Some small percentage of it may have been borrowed billions of years ago from a star that has long since died. It also means that other solar systems have been doing this too. Just as our sun captured objects, our sun lost objects. Worlds that originally formed around the young sun were almost certainly flung outward during gravitational chaos with the giant planets, or stripped away during close stellar encounters in the cluster. Some of them are now wandering the galaxy as rogue planets, drifting between stars, dark and silent. Some of them have been captured by other systems. Around some other star, somewhere in the Milky Way, there may be a planet quietly orbiting in a tilted, eccentric path, looking, to whatever astronomers might one day study it, exactly like Sedna looks to us. Born here, captured there. A piece of our family, hosted by a stranger. Astronomers now estimate that the number of free-floating rogue planets in the Milky Way alone may rival or exceed the number of stars. Some of them were ejected. Some are caught between systems. Some are being captured right now, somewhere out there, by stars that didn't expect to receive them. This is happening constantly across the galaxy. It has been happening for nearly 14 billion years. The Milky Way is not a collection of separate, sealed solar systems. It is a long, slow, ongoing exchange. Worlds passed back and forth, identities scrambled, origins blurred. The hunt for proof in our own backyard is heating up. Vera Rubin Observatory has begun a 10-year survey of the entire visible southern sky, scanning the same stars and the same dark patches every few nights. Anything that moves, anything that wasn't there last time, will be flagged. Astronomers expect Rubin to find tens of thousands of new outer solar system objects, many of them detached, many of them on tilted, suspicious orbits. If Planet 9 is out there, Rubin has a strong chance of catching it. The James Webb Space Telescope, with its infrared sensitivity, will be able to study the surfaces of any sufficiently bright captured object in detail. The extremely large telescope being built in Chile will give us tools sharper than any human has ever pointed at the sky. And then there are the ideas that go further. Some scientists are drafting proposals for a dedicated probe to a detached object. A spacecraft sent across decades of empty dark to actually visit one, to land, to analyze, to touch a surface that may have last seen sunlight from a different sun. Such a mission would take 50 years from launch to first data return, and would almost certainly outlive everyone who designed it. But it would answer the question, for real, in a way no telescope ever could. The question is no longer whether the sun stole anything. The question is how much, from how many, and which of the worlds we now consider ours were not always ours at all. There is something quietly humbling about this. Our solar system, the place that has been our entire physical context for as long as any of us has been alive, the place we call home, is not a closed garden. It is a way station, a wide spot in the road of the galaxy where things drift in, drift out, get caught, get released. Some objects we host now will be gone in 1 billion years, lost to passing stars. Some objects out there in the dark are not waiting to be discovered, they are waiting to be returned. Our solar system is older than humanity by a factor of millions. It has had time to do things we are only now beginning to imagine. When you picture Sedna in your mind, hanging out there in the dark at 76 times Earth's distance from the Sun, drifting through an 11,000-year orbit it never agreed to, it's worth thinking about where it came from. Some other star, smaller or larger than ours, brighter or dimmer, with planets around it that may have been Sedna's siblings. Whatever family Sedna had is gone. The star it remembered is, by now, somewhere thousands of light years away, probably already dead and faded, its planets long since dispersed. Sedna kept moving. Our sun caught it, and it has been here ever since, moving in the slow rhythm of a captive, neither leaving nor arriving, bound to an orbit forced upon it by a star that is not its own. If Planet 9 is out there, it has been waiting for us in silence for a very long time. Cold, dark, unspeaking, holding the chemical memory of a different birthplace. When we finally find it, and I do think we will, sometime in the next 10 or 20 years, we will not just be discovering a new world. We will be opening a window onto another star's family, onto a sibling solar system that died, or scattered, or simply moved on, leaving one of its children behind in our care. We will not be discovering a planet. We will be reuniting in some quiet way with a piece of someone else's lost system. And the sun, that thief, will keep its face still, its light steady, holding the secret it has held for 4.5 billion years, as if nothing happened at all. That's it for this video. Thanks for watching, and I'll see you in the next one.